All right, next up we have Linda Schott from the University of Idaho now. And she's going to talk to us about her work that she did as a student, correct?
Good afternoon. I know I'm the last person that stands between you and the posters, so we'll try and get through this. So this was part of my dissertation work at the University of Nebraska-Lincoln. So my co-authors were Umberto Blanco-Conchi and Amy Schmidt. So we know that manure is a great soil amendment, but to take that knowledge to crop producers that are not associated with livestock production is a pretty big barrier. Crop producers cite odor and neighbor complaints, costs of transferring the manure, weed seed, and inconsistent nutrient application as reasons they don't use the manure. And as a result of that, manure is just not utilized. So if you look at this graph, manure production has increased pretty substantially over the last couple of decades, as has, manure production is here, sorry about that. Agricultural production land has increased, but manure usage has remained very stagnant and very low compared to the production of the manure. So if you look at this is a pretty big gap, but inorganic fertilizer usage has increased, and these create massive nutrient imbalances in local regions. And so as those of us who are working to alleviate these issues, we need to ask, how can we get crop producers to utilize this manure? And I think that soil health is a really great vehicle for this. Soil health is not a new term, but it's recently gained a lot of traction in the agricultural world, and farmers are very aware and crop producers want to improve their soil health. And practices that increase soil organic matter increase soil health as a general rule. And before I move on, I realize soil health, just for those that may not be familiar with the true definition, it's the capacity of the soil to function as a living ecosystem. And the main difference between soil health and soil fertility in previous terms that all mean relatively the same thing is this biology, the biological aspect of what can the ecosystem of the soil, how is that impacting these other properties of physical and chemical that we generally think about with soil and soil fertility. And so to think about this, if soil health is increased with increased soil organic matter, what is soil organic matter made of? And it's microbes. It's the biology. Microbes create and make up the soil organic matter. So, quick soil lesson. Soil is mainly mineral particles. About 1 to 6%, depending on your region, is soil organic matter. And that soil organic matter is made up of stable humus, readily decomposable materials such as manure, and also microbes. So microbes make up, and then they also create soil organic matter. So as they break down all of that readily decomposable material like crop residues and manure, they're also creating more organic matter. And there are more microorganisms in a teaspoon of soil than people on Earth. So they're very important to the soil. Oops, I don't know what I just did. Sorry, I hit the wrong button. And microbes are important for nutrient cycling. They supply nutrients to plants, decompose organic matter, improve soil structure, and suppress pathogens. So it's really important to the soil and those physical and chemical properties. And it's all interrelated if you think back to that Venn diagram that I showed. And in order to support microbes, you need to understand a little bit of how do you support them? Microbes are like humans. They need food, water, and shelter. And so to think food is carbon for them, water, and then a suitable habitat, which is the soil. And so the objectives of this work after that long introduction of Soil 101 was to summarize the results of how does manure impact soil health properties. So there's been quite a bit of work, as I'll show, on how manure impacts individual soil properties, but not the whole matrix. So a lot of it has been done for chemical and some physical, but how can we repackage the previous literature and use this to convince farmers to utilize manure? Because there's this interest in improving soil health. And then also to describe future research needs related to soil quality and manure application. And so it was a pretty big undertaking. There's a lot of literature about manure related to soil properties. And so I used a search engine and a bunch of keywords related to manure and looked at different physical properties. I'm afraid to hit this button. Physical, biological, chemical properties, and then some about climate resilience, because that's also important in this conversation. And then I did sort of look at yield and nutritional value, but it's pretty mixed, and I'll explain a little bit of that in a second. And in order to be included in this literature review that I did, it had to be a replicated field trial. Only organic amendment application was different between the treatments. It had to be written in English because I speak English, and it had to be statistically analyzed. And of that, I found 200 plus papers. 163 were deemed relevant under those 4 criteria, and they included 15 review articles, and 14 of them had one property from each of the physical properties, biological, and chemical. So they had at least one from all those banks, so I categorize it as soil health. And if you think about it in terms of the total number, there's really not that many. So that's already a pretty big gap, but a non-intentional gap, since this is a new way of thinking about soil properties. So what I found is that manure increases soil organic matter compared to inorganic fertilizer. And this isn't surprising because manure contains a lot of carbon, and as I talked about before, carbon is the food source for microbes. So that carbon is really available, and so these microbes are consuming the carbon in the manure and creating, their populations are growing, and they're creating more soil organic matter. So if you think manure increases soil organic carbon 10 to 100%. And this is really dependent on the methodology of the study, and I'll talk about that a little bit at the end as well. But it's a really wide range, but it does significantly increase it. And then about 20% of the manure carbon that is applied will be retained in the soil system in the long term. And again, that's very variable. And if you add the carbon, and then the carbon enhances water holding capacity, increases nutrient retention, and improves the structure, which all then lead down, because you're improving the soil microbe environment, you're providing them food, water, and shelter, and they are then improving their own environment. It's kind of this awesome feedback loop that happens. And so then as a result, soil organic matter increases again approximately 10 to 100% in the long term. This is not a short-term, real quick result, but through time in these long-term studies. Manure increases soil biological populations compared to inorganic fertilizer, and I just like using this graph because it just shows the food web. So as I stated before, because the organic matter and the carbon increases, now you have an increased food supply for these microbes. So bacteria and fungal populations increase because they're the primary feeders on the organic matter. But there's really no change beyond this next step. But a caveat is there really are not that many studies that have looked at these upper food web players, and not in the long term necessarily. So that's a pretty big research gap as well that I'll talk about in a minute, but just want to, and then, but nematodes, both beneficial and pathogenic, can increase, but there aren't that many research projects on those as well. So nematodes that feed on fungus and bacteria, they increase in general because they've got an increased food supply. Sometimes the root feeders also increase, but there's not that many studies. Another point that's not demonstrated by this, but the diversity of these populations are unchanged. So the total populations increase, but there's no difference in the percentage of fungi to bacteria or the types of bacteria or the types of fungi that change. It's just the total populations that change from the research that has been done. And the microbial, these groups, the fungi and the bacteria, they increase at approximately the same percent, 10 to that magic 100% compared to inorganic fertilizer. It's the same as those lower groups. And then earthworm populations also increase because they love eating manure. Oh, and yeah, the root feeders are mixed. So then, because the fungal and the bacterial populations increase, soil structure also improves because fungi and bacteria, fungi create these hyphae that go out into the soil and they tie particles together. And you can see them, these fungal hairs here. And so they create these aggregates and they hold it together physically. And then bacteria, as they feed, they create these byproducts that are sticky like glue, and they glue soil particles together. So the two of them are improving soil structure, so they're increasing aeration. Potentially, depending on the soil type, you can increase water holding capacity, but infiltration is generally increased and bulk density is decreased because you have more airspace, which then makes a better environment for the plant to grow. So in conclusion, manure improves soil health, and it's mainly because it's supplying a readily available carbon source to these microbes. Manure provides plant essential nutrients, NPK, as well as micronutrients that are other macro and micronutrients that plants need to survive that inorganic fertilizers have to be more targeted for. It decreases compactability. If you think about soil organic matter as a sponge, when you have a wet sponge and you squish it and it pops back up, it's the same thing in soil. When you increase organic matter, you can put a heavier piece of equipment on it when it's not really wet. That's a pretty big asterisk, and it will recover quicker than soil that is lower in organic matter without the manure. Which I think is a pretty good point to producers who maybe don't want to apply because they think that it's going to increase compaction. In the short term it might, but the soil recovers pretty quickly. It increases nutrient cycling and nutrient retention because of those microbes, decreases bulk density, and increases aggregate stability. So you just have a better soil because of those microbes. But there's still a lot of knowledge gaps related to this. I went through a lot of studies, as I pointed out, and the methodologies run the gamut. There's not that many studies that look at single applications. A lot of these studies applied at a high rate of manure year after year after year. And then the conclusion from that is phosphorus builds up and it's an environmental risk. And I mean, as a producer, what do you do with that information? And so I know that producers are doing really great things, and we need to, as a research community, think about, and extension professionals doing on-farm research, thinking about how are producers using this manure and what can we do to complement what they're doing and what they should be doing. If we continue to do research year after year of high rates, then we get the same conclusion and we're not really advancing science. And along those lines, nutrients are rarely balanced when you're comparing inorganic fertilizer application to manure application. So a lot of them are either you're applying a full perfect rate of inorganic fertilizer, which you're able to do with inorganics, and then either an arbitrary rate of manure that there's no matching, or a nitrogen rate, which again has the phosphorus issue. Or you're applying inorganic fertilizers on both of them, and then you're just adding a little bit of manure to one of them. And so it's really hard to make comparisons on these properties when there's those imbalances. And I think that there's a way that we can do some research on supplementing manure application with inorganics to keep the phosphorus in level appropriate. And I know that that's already occurring. It's just not necessarily in the literature yet. There's a few of them, but not widely. And then, looks like when I was updating this presentation, my computer died and it didn't save. So I was copying and pasting, and noticing that it now says decreases bulk density. But some other things, some other gaps is that there's really no research, not a lot of research on the biology. And that's really important. Like I said, everything tied back to the biology of why these awesome things are happening. And that's what a lot of producers, and talking to them, they're interested in how manure and how soil health practices impact the biology of their soil. And so that's necessary as well. And I just want to acknowledge the Soil Health Network and North Central Region Water Network for their funding, or Soil Health Institute, and then also the lot of help I got from some undergraduate workers, Mara Zelt and Ashley Schmidt. I will be happy to take any questions. I think I have a couple minutes. Yes.
Did any of the studies look at separated solids, the separated liquids manure applied, and what kind of organic matter increase from that?
I don't recall the specific tech. There was only a handful of studies that dealt with a liquid hog product, and I can't remember the individual results from that. But as a blanket statement, on most of these properties, it didn't actually matter what type of manure it was or how it was applied, if it was in the long term. In the long term, it seemed to have these same things. But and then always the huge asterisk, individual results will vary. This is taking a lot of information and really boiling it down to the smallest bite size. Yes.
You had mentioned that there weren't a lot of single application studies on the manure side. There are on the compost side. So if you do a literature search, there's like the Marine Carbon Project looked at single-use applications.
Yeah.
The lady at lunch actually mentioned there was a plot that Utah State did with a single-use compost application, and then monitoring for 20 years.
Yeah, I mean there were definitely some, but just looking at the bulk of the research, yeah. But I will look into that.
Any other questions? You're just dying to get out of here.
Yeah.